Next up, we have Graham Dumbleton, ModWhiskey maintainer extraordinaire, here to tell us all about hosting Python web applications.
It really worries me, the sort of reputation I have out there, because, why? But Danny's talk yesterday was interesting because it's the same thing as why do people look up to people in the community? And it's just, it's interesting to see the attitudes. Anyway, my talk, hosting Python web applications. Is interesting in having a mind fade out of his name now, the talk earlier, where he was mentioning about WSGI and how WSGI sort of unified the web hosting world because it's given one solution. So when I talk about hosting Python web applications here, I'm particularly talking about WSGI. I'm not talking about the other things that are available. I will briefly mention them. So, web applications in the Python world. I actually find it very interesting that there isn't actually many standalone web apps that have come out of the Python community. The main ones you hear about are Plone, Track, and MoinMoin. You look to some of the other web communities, PHP and so on, there's a lot of end-user applications. Drupal, obviously really large on the PHP, but you don't get a lot in the Python web community. But what you do get in Python web community is a lot of web frameworks. And so although you don't see a lot of end-user applications, you've got a lot of frameworks out there for building your own, and that's what's more important to us. With those frameworks, most of those frameworks generally bundle their own web server to make your development easier. Some of them have the ability to perform code detection and will automatically restart themselves when you make a code change. For those servers, they generally fall into two categories based on how capable they are. So we have those which are regarded as development only. So these ones are generally based on modules which are available in the Python standard library. They're definitely only suitable for development and definitely not adequate for production use. The sort of shortcomings that they have, some of the main ones are the lack of decent concurrency support. Essentially, they're just not apt to handling the rigors of a high-load production website. They've not been security audited very well or at all. And if you put them on your website, they could well just blow up. So definitely for those ones, okay, great for development, but steer clear of them for production. For some of the other web servers, then you have the other options of Paste, Rocket, and CherryPy as WSGI servers. These are claimed to be suitable for production use, and a lot of people take that and say, yeah, great, we'll use it. So they are a reasonably safe option, but your mileage may vary depending on the sort of site you're running. You'll often see benchmarks comparing these different types of web servers, and people get mixed results with them. Partly that's because people have unrealistic ideas of running benchmarks, and they will expect things to work under 10,000 concurrent connections on their Hello World program, and they wonder why some particular web service sort of trails off performance after a while. But they are certainly a better solution than the ones which are just a development server alone. They're not a complete solution. Generally, you still need to have a separate process management system in place to ensure that they stay running. And they're definitely not a good solution for static file serving. Basically, to do static file serving in any WSGI server, which is a pure WSGI server, then you have to actually have a WSGI application component which can do that static file serving, and that's where you start to get processing things through Python code, and static file serving is going to be nowhere as good as a dedicated web server. For most of for all of those ones, because of the static file handling, for other reasons, generally it's recommended you stick them behind a more traditional web server. Independent web servers. These are ones which are available separate of a framework, and there are lots of them, and I've even stuck pants down the bottom there after the talk yesterday. It's sort of interesting. There used to be that the joke was that in the WSGI world, that WSGI frameworks are so easy to write that everyone wrote one. These days, it's more a case of everyone's writing their own WSGI server, not the framework. So there's a proliferation of them, and these are the main ones you'll hear about. Overall, they're a bit of a mixed bag. Again, it's really interesting to see the benchmarks when people try and compare these. Of these, the Goonicorn is probably, well, definitely is the best of the standalone ones that are available. Certainly the flavour of the month and the one that's regarded as the cool web server to use. But like with Paste, Rocket and the CherryPy Web WSGI server, it's still recommended that you put them behind an existing traditional web server, whether that web server is used as a proxy. And that is because of the front-end web server being able to be used for static file handling, but there's also some other attributes which come from putting it behind a front-end web server, which I'll explain soon. So I keep talking about front-end web proxy. So what actually are we talking about there? So what we're talking about here is we have a front-end web server, which is the thing that's accepting all your HTTP requests from the web browser clients. It then will, if it receives a static file request, will deal with that static file request itself and send the response back. For the request that's coming through, which is destined to your dynamic web application, your WSGI application, then it will actually proxy that request through to your backend web server or WSGI server, and it will use the HTTP protocol again. So it's introducing a extra step, but that's the sort of architecture I'm talking about. So all requests for the dynamically generated content proxy back through. And I guess overall what you're doing here is that you're saying that no one web server is actually the complete and ideal solution for everything. You'll never get that situation. So this is where you need to start thinking that, and this is where the problem with people try and benchmark all the different servers and try and say which is the best, is that you can't do that because you're benchmarking for one particular use case, usually a Hello World program, which is a totally unrealistic use case, and saying, great, I'm getting the best performance for that. That is my perfect solution. It's never going to be the case. So here for a dynamic web application, you're going to pick one particular web WSGI server which suits your particular requirements for your application. Static file serving, we're going to use a different web server. So you start doing a model where you mix the different bits because it just makes more sense than trying to do it all in one solution. So you do this and you get static file handling speed, which is far superior. Other benefits of using a front-end web server is that you can start to implement caching in the actual front-end web server. And this is important because WSGI is a what's called a blocking, it has blocking API effectively. What that means is that it's generally going to be using a thread pool to handle requests. And you only going to have a limited number of threads available to handle those requests. So if you can actually avoid a web request getting to your web application in the first place, that is a boon because it means it's one less thing that your web application has to do and it can be doing other stuff at the same time. So having a front-end web server allows you to start implementing caching in the front-end web server. Especially with some of the web servers, which I'll mention in a moment, is that it's not just caching, but you can actually start to isolate your web application, which is doing the real work, from a slow browser. Now, most of people here, okay, we're Australia, we don't have fast internet, so it's everyone here at home. You're not on a multi-gigabyte LAN connection onto the internet. You're on slow ADSL. And if you're lucky, you might get 10 megabits per second. Unless if you're Russell, no, you might get 1 or 2. Perth hasn't discovered the internet yet. And the reason why that's an issue is that if you've got a slow web browser which is talking to your application directly, and it's like trickling data for your request headers and your request content when posting, that's tying up, again, that thread which is in your web application. If you put a web server in front, especially something like Nginx, then it will actually buffer up the request headers and actually will buffer up to 1 megabyte of your request content before it even bothers to proxy it through to your web application. So this is where you get sort of isolation from your slow clients, and that's one of the great things for having the front end. And also part of that is you can have the web application in the front will also handle keep alive to the browser client as well, and that's a feature of HTTP 1.1, whereby when a browser makes a request, it will actually hold that connection open in case it wants to do another request to the same server. And you know, how long a particular web server will hold that connection open can vary. But again, it's just if your actual web application which is doing the dynamic stuff is holding that open, again, you're limiting resources, and so you're bumping off this to the front-end web server, and the back-end server doesn't have to handle it. So good options for a front-end web server. Anything that is using asynchronous or event-driven system type to implement it. So Nginx, Cherokee, and Leidy. Apache is not necessarily really a good choice because of the fact it's using a threading model, and you're going to have the same problems as if you actually had your web application handle it directly. Alternatives to Apache. That previous example we had using HTTP protocol to proxy through to a backend. We can replace HTTP with FastCGI. It's a protocol that came up many years ago. It's sort of, it's a more binary protocol. Your backend is not then strictly a web server as such, it's more an application server. And what happens now is that sitting on top of the FastCGI layer, or it's a wire protocol, so sitting on top of the socket in the application server is a FastCGI to WSGI adapter, and that way we get you ability to run WSGI on top. The good points for a FastCGI, it is language agnostic because it's actually a socket wire protocol, whereas WSGI is an API within the programming language itself. And web servers, some of them, especially with Apache, are able to actually handle process management, so you don't have to worry about it. So you don't need a supervisor, a separate supervisor or monitor to look after the processes. And you also have got the ability to run your web application as a separate user. And they also have request timeouts and other features they have. Bad points. FastCGI is a method you'll often find in web hosting, shared web hosting environments. The problem is that it's very popular for hosting PHP, and as a result for Python, generally the configuration that the web hosting companies use is biased towards Python and towards PHP, and basically sucks for Python. They'll set it up so that FastCGI processes will be spawned up single-threaded, might allow a lot of them, but it will actually kill them off quite quickly. Because the difference between PHP and Python is PHP effectively loads in the whole app structure of each request and then throws it all away. So it doesn't matter if it kills off the process every so often. Python has a preference for having a persistent process. So that's one of the really bad points in terms of FastCGI, especially if you use it in its default configuration or on a web hosting environment where it's generally set up for PHP. My other complaint about FastCGI is that deployment for Python tends to be really a bit more complicated. You talk about PHP, you just have to drop a PHP file in a directory and it will all work. You don't have to worry about it because the actual configuration of the hosting environment has been set up to do everything it needs to do. For WSGI, you generally have to create a main, you have to import FLUP, you have to actually initialize it and tell it then to execute your application. It would be very, very simple to actually set up a mapping in your FastCGI configuration, mod FastCGI or mod FCIGD, to allow you to just drop a .wsgi file in there with an application entry point and not have to worry about all that startup code. But no one's done it and no one seems to care, and I don't want to deal with all the web hosting companies, so I haven't bothered either. Recent alternatives to FastCGI, we have UWSGI, Fusion Passenger, and Mongrel. UWSGI started in Python, it's now branching into other languages. Fusion Passenger and Mongrel started in Ruby, and they've now started to add in support for Python and WSGI, although they both sort of regard as experimental, I think, at this point. UWSGI is a similar architecture to FastCGI. It uses a slight variation on another protocol called SCGI. which was intended to be a simplified version of FastCGI. In all of these cases, I think, actually I could be wrong there, the process management still is distinct from the web server. So you have to look at either the systems have to provide the process management itself, or you still have to use something separate. Now the reality is, as I was mentioning before, is that PHP sort of dominates the land with web hosting. So web hosting systems tend to be set up for that. So what we're going to end up with is that web hosting companies are going to continue to be bothered with PHP because it's a huge market share compared to Python. So we're never going to have a situation where we get good Python web hosting with FastCGI. Some of them are sort of DreamHost in particular, they sort of try to say, oh, we'll cater for Ruby, and they dropped in Fusion Passenger, which does allow you to have WSGI as well. But ultimately, we're never going to get a good experience, I think, out of cheap web hosting. So what we need to look for is these new type of web hosting companies that are coming along. We have .cloud, which is doing multi-language with UWSGI. And we also have things like Gondor.io API and Django Zoom. And he's given me 5 minutes, which means I'm nowhere near finished. So what we have still is an elephant in the room is Apache. Apache still takes 60% of websites, in contrast to Nginx, which is not 10%. A lot of experience with Apache. It does have its detractors. People accuse it of being bloated and hard to configure. But partly that is Python's got a raw deal here because people set up Apache for PHP and then they try and run Python on top and they find it runs like a dog, uses lots of memory, and that's partly their own fault because they didn't set it up properly. For Apache, we have ModPython was an existing way of doing things. It's dead, shouldn't be used any longer, but it does hold the prime name of ModPython. And if you go and look at Google Trends, you'll still find that ModPython and ModWSGI are currently fighting for who gets the most traffic on searches. It's still very popular on searches. But yeah, just stay clear of that one. So obviously, as I said, ModWSGI, it was intended to replace ModPython. Learnt from ModPython's mistakes. It tries to focus on just being a bridge for WSGI, and it has multiple modes of operation, which I'll quickly try and go through here. We still have embedded mode, which is basically how ModPython worked. This is where the interpreters run inside of the Apache child processes. And if most people, their sites don't actually have a great deal of load requirement, and you could do this. You definitely don't want to do it though if you're using prefork NPM in Apache, because it's actually multiple modes again in Apache. You can set up as prefork or worker. Prefork is single-threaded processes, worker is multi-threaded. You definitely want to avoid, if you can, using in prefork NPM though. So use worker NPM, and if you use worker NPM, you can get away with using Apache. Same Apache for static file serving as well. Daemon mode is the other mode. This is effectively similar to FastCGI and UWSGI, where the actual bit of proxying going on here to a back-end process, daemon process. Using Apache, though, you don't get a lot of the benefits of sticking an async server in front because Apache is still threaded and you've got resource limitations there. But again, it's mostly okay for most people's sites. What you can do to make it better, though, is take Apache with ModWSGI. Oh, nope. Well, Keynote just totally vanished. I had a pop-up. Stupid firewall stuff went off. Okay, yeah, you can put Nginx in front of Apache as well. Okay, then this starts to bring some of those benefits, talking before about having Nginx in front with isolation of slow browser clients. You can offload static file serving to Nginx as well. And this sort of model, okay, Apache, people might say, oh, well, Apache is quite heavyweight, why would I use that instead of Unicorn in that sort of situation? Well, if you've got a lot of investment in Apache and using other stuff, you might be still using PHP, you might have a reliance on Apache authentication and access controls and things like that. So it's still, and also the fact that people understand Apache and much more popular, so it's still a good solution. Oh, okay. I'll just go back to this one, if I can. Yeah. In this particular case here, we still actually have Nginx, Apache processes doing proxying then to ModWSGI and daemon mode. What you can also do is because ModWSGI has both embedded mode and daemon mode, you could, if you want, actually just get rid of daemon mode and use embedded mode of Apache behind an Nginx front end. And you'd only do this, though, if the Apache is basically dedicated to your particular web application. If you wouldn't do it if you're running PHP or doing any more complicated stuff. And you do really need to know you have to really know how to configure Apache properly. But yeah, Worker NPM, you're still going to be safe in the situation. But yeah, if you really know how to configure Apache, then you can actually use pre-fork NPM, and that has some benefits because you're avoiding the multi-threading GIL issues. So overall, there's a lot of options, which I sort of tried to quickly cover there. Too many options. What should you use? Well, the hosting mechanism is not usually where the bottleneck is. So it's actually really important to just use what you feel comfortable with, what you're able to administer. Identify that different servers have different strengths. So you want to test things with your particular application, make sure the thing you choose actually works, not use Hello World benchmarks. And you also I've here talked about WSGI and essentially it's a blocking thing. If you're doing a lot of long polling with your application or comment style things, you may consider instead using those, but you also may consider using a mix and separate your applications. Send some URLs to WSGI and some off to Comet application. Most popular, obviously, Apache, Unicorn and UWSGI, and I'll get the last slide up. But overall, my suggestion is don't waste your time worrying too much about the web service, especially initially. Concentrate on removing the bottlenecks in your actual application itself and look at improving your database performance, page rendering times, caching, and so on. So don't prematurely try and optimize things by trying to identify which is the quickest server out there because you're just wasting your time. And also consider looking at monitoring tools for production. And where I'm working at New Relic, we're working on something which I think will be really great for that. And you can come listen to my lightning talk about that later. And also Moonin, which is more host or external testing, whereas New Relic, we're looking at performance monitoring from within your application itself. So the hosting mechanism is only a small part. Don't get too obsessed with it and don't prematurely optimize. There's a lot of things you can do elsewhere, which is going to do a lot more to improve the performance of your application. And if I'm totally out of time,